Many of you probably heard of this story about the Doomsday Glacier, the West Antarctic Ice Sheet, which has been talked about a lot. Scientists are monitoring it, studying it, and worried about it for good reason. It's a complicated place, ocean warming, wearing out glaciers from below, and breaking them off. All kinds of things are happening, and yet scientifically we have to be much more robust. We already discussed one case where people kept saying the Atlantic meridional overturning may collapse soon by 2025, as the headlines blared recently. As excited as we are about science and saying we are in danger, we should watch out, we should still be very careful about exactly what the science is saying. Some conjecture is always involved in saying this is melting at such a rate, so this could collapse by then, by when, all these things, they are important. So here a short news type article by Paul Woosen, who writes very well. The Thwaites Glacier is not expected to collapse by 2100, but it still may add 6 centimeters to global sea levels by then. Okay, so this appeared in Science very recently at the end of September. I'm recording this in November, so I'm a little bit behind still. So what does it say? Doomsday delayed at vulnerable Antarctic glacier. Thwaites collaboration finds glacier has stabilized somewhat in the short term. It's complicated science, so one should not be, too harsh on people who talk about this in an excited way, but yet we have to be careful, right? So let's read some text and look at some figures and then the final words on this topic in the article. Antarctic's Thwaites Glacier isn't called the Doomsday Glacier for nothing. Where the Florida-sized ice sheet to melt away, it could raise global sea level by 65 centimeters. Glaciers lock away water evaporated from oceans typically, and if they melt, they're going to put it back, right? And because it's a keystone that holds back other ice sheets from flowing into the ocean, its disappearance could unlock a total of more than 3 meters of global sea level rise. So Thwaites is ahead and can slip off or break off or melt away, whereas glaciers build up behind. There's a grounding line, and then there are many ice sheets behind, and if one is gone, then they may all accelerate down into the ocean or melt away. Okay, so you have to be careful. In 2018, US and UK funders created the 100% International Thwaites Glacier Collaboration ITGC to probe the ice and its future with a concerted campaign of fieldwork, submersibles, remote sensing, and computer modeling. ITGC took stock of what it has learned at a meeting last week at the British Antarctic Survey in Cambridge, England, a final gathering as its 8 projects wind down over the next year. A key conclusion is that some of the worst case scenarios, as the runaway collapse of the iceberg carving front of the glacier, which juts into the ocean as an ice shelf, the worst case scenarios are unlikely this century, says Robert Lartrell Bass, marine geophysicist and co-lead of the project. That worry, he says, is not the huge monster it might have been 10 years ago. So people were calling for, such studies based on the guesswork that it was about to collapse. Instead, preliminary results from one of the ITGC's modeling groups suggest that in coming decades, Thwaites will steadily retreat but not collapse, contributing up to 6 centimeters of global sea level rise by the century's end. That's still a major fraction of the 38 to 77 centimeters of rise that the latest UN climate report estimates will occur by 2100 because of melting in Antarctica and Greenland. So projections of IPCC CMIP6 include sea level rise, and it will happen even if humanity suddenly halts greenhouse gas emissions, given the warming that's already occurred and the ice sheet's slow response time, says Daniel Goldberg, a computational geologist at the University of Edinburgh. Yes, we have already emitted CO2, accumulated, the warming will continue and already has happened, and glaciers keep on doing their thing on longer time scales, and it's a irreversible change, right? Glaciers can melt fast, but rebuilding will take a long time. There are other exciting things being tried, like putting a screen on top of the glacier to prevent direct sunlight and melting and so on. Maybe if there is a good article, I'll cover that part elsewhere as well. My beautiful bird is back here. Okay, let's not get distracted. Longer term, the outlook is still grim. Under a worst case scenario for emissions, Thwaites and many of the ice sheets it buttresses could collapse by 2300, adding more than 4 meters to sea level, according to an estimate of the total Antarctic losses published this month in Earth's Future by a large collaboration of modelers, including the ITGC members. Models that featured aggressive emissions cuts, however, saw no such collapse, which means there are lots of uncertainties based simply on scenarios once you go back beyond a couple of decades, as we have seen elsewhere. And paleoclimate scientists outside ITGC are finding increasing evidence in ice cores and even octopus DNA that this region had lost vast amounts of ice some 125,000 years ago, just before the last ice age started, which ended about 12,000 years ago, and the temperatures were similar to today at that time, so it's a good analog. Glaciologists recognized the unique vulnerability of Thwaites and other glaciers in West Antarctica in the 1970s, way back when. The ice fills an immense lowland that sits below sea level and deepens inland. So depending on which way it's sloping, the grounding line, you can accelerate the melting and so on, which I've discussed elsewhere. That topography raised fears that once Thwaites pulls back from a bedrock ridge, or still that helps slow it down, warm ocean waters will rush in, eating away at the glacier's underbelly and accelerating its retreat. Did I read it correctly? That topography raised fears that once Thwaites pulls back from a bedrock ridge, or still that helps slow it down. I don't know if the sentence is written correctly. Warm oceans will, so once there is a topography which can allow warm waters to come into a dip and then accelerate the melting. Two of the ITGC projects used controlled blasts to probe this bedrock with seismic waves. It's a nice methodology that you can look up. Because of pandemic delays, we got some data, but not as much as I would like, says Sridhar Anandakrishnan, a glacial seismologist at Pennsylvania State University, who led one of the projects. He puts little dynamites in glaciers to measure seismic waves to get various properties of the glaciers and so on. Still, his team found that a choppy mix of hard rock, sediments and lakes underlie the glacier. The complex topography could make it difficult for models to predict how fast Thwaites will slide and what it will catch on once it retreats past the sill. For now, retreat can only go so far, says Jeremy Bassis, a glaciologist at the University of Michigan. It will take a decent-sized punch to get it off that sill and into deep water this century. So, some good news there. So here is the picture. Thwaites Glacier is sitting here. Ice flows towards the ocean down the slope. Even though it's sitting in a lowland, glaciers can build and have a flow. So ice shelf is sticking out on the ocean. This is West Antarctica overall. Ross Sea Shelf is here. West Antarctic Sheet boundary is here. And the idea is that if this begins to have trouble in the grounding line and melting at the edges, then this entire thing begins to become vulnerable. Here is the Ron ice shelf, and this is a zoom in of of the Antarctic subcontinent with the Southern Ocean around it. So an Antarctic plug remains for now. You can think of this as the plug that is holding this massive thing back. The vulnerable Thwaites Glacier is the keystone of the West Antarctic Ice Sheet. If it melts, it could unleash more than 3 meters of sea level rise. An international campaign has found that Thwaites is unlikely to fall apart this century, but Beyond 2100, melt is expected to accelerate, posing a looming threat for future generations. So obviously we have a normative call, a value call to make to see, do we want to worry about what happens after we are long gone, by after 2100, and try to save this, or do we say let them worry about it? Although to jump ahead, although some of this might seem like good news for Thwaites' immediate future, the two ITGC paleoclimate projects make it clear that the glacier has a history of being unpredictable and fast changing. In one project, researchers drilled through the ice to underlying rock near Thwaites, measuring in the lab when those samples were last exposed, to bombarding cosmic radiation and sunlight. So you have evidences buried in the bedrock which can say when it got exposed to the atmosphere and the cosmic ray radiation. Those rocks showed that Thwaites and its neighbors were at least 35 meters thinner just several thousand years ago, according to a study published last year in the cryosphere. The findings suggest that the glacier can recover from past losses, so a few thousand years ago to now it has gotten thicker, although recovering from today's thinning would require the world to rapidly curtail its greenhouse gas emissions, says Joanne Johnson, a geologist at Bath. And on societal timescales, 3,000 years is an awful long time to recover, she says. So if it keeps going and keeps increasing sea level, obviously there are going to be many, many cascades into the societies, coastal cities, etc., and islands. The second paleoclimate project extracted sediment cores from undersea peaks to chart how far seaward Thwaites extended in recent centuries. In a study published this year in the Proceedings of the National Academy of Sciences, the researchers found that the retreat of Thwaites and its neighboring Pine Island Glacier, here is the Pine Island, where was it? I just mentioned it, but anyway, let's leave it here. Okay, sorry about that. So what did it say? The researchers found that the retreat of Thwaites and its neighboring Pine Island Glacier began in the 1940s, before the surge of the modern day warming, perhaps tipped by a strong El Nino in the Pacific Ocean. So the anthropogenic impact, let's say, took off after I'm having trouble speaking, after 1950s, 60s, then something that appears to have started before would have been related to some big perturbation like El Nino, which can send warm waters and heat waves down into the polar regions. Using an underwater probe, the team also examined a seafloor ridge on which the glacier once rested. The probe identified scars left on the ridge by the ice as it was lifted and lowered by the tides. So when ice shelf jets out into the ocean, it's heaving because of the tides. The tracks showed that for a year or two last century, I cut it off at the wrong time. The probe identified scars left on the ridge by the ice as it was lifted and lowered by the tides. The track showed that for a year or two last century. Okay, these tidal signatures. Thwaites retreated up to 3 times faster than the present, says Julia Wellner, a glacial geologist at the University of Houston. Everything we get keeps hinting at how dynamic it can be. So it has behaved crazily before and recovered. So now what are we doing that will change its behavior or make it go kaput, right? That fickleness makes it hard to nail down Thwaites' future. So do remaining gaps in the data. Ananda Krishnan, for example, couldn't map the 70 kilometers of bedrock just inland from the ice shelf, so he can't say with certainty how ridges there might forestall Thwaites' retreat in the future, and the ITGC members could not do field work on the glacier's faster moving western trunk, so it is too broken up. Sorry folks, I haven't had breakfast and it's about 12 p.m. so I'm starving, lunchtime coming up. And the ITGC members could not do field work on the glacier's faster moving western trunk as it is too broken up and hazardous. But another big effort like ITGC is unlikely anytime soon, just funding-wise, given that the primary US ITGC funder, the National Science Foundation, is short of funds and logistical support for the work in Antarctica, and then we have just got a new president. Wow, right? I don't think NSF wants to hear that World waits for 10 years, Ananda Krishnan says. So they put a lot of funding, they wait for data, and then they say, wow, you sit and work with this data and don't ask for such big amounts again anytime soon. That's the way funding works, but there are many priorities. Everybody thinks their work is the most important, so NSF and NSF program managers have a hard time managing the budget they have. Even though they keep getting some increases, fortunately, they have priorities growing as well, and we have to see how much priority this particular glacier should take, considering its impacts are decades to centuries away, right? But nonetheless, some good news that maybe this century we will not see the collapse of the West Antarctic ice sheets. Okay, ice sheet. Let's leave it here.